Well, welcome everybody to this afternoon session. We have an hour and a half here. We're really looking forward to the session. I'm Matt Jones. I'm the Director of Informatics at UC Santa Barbara's National Center for Ecological Analysis and Synthesis, and really looking forward to working together on this. I've been heavily involved in building cyber infrastructure to support data management and sort of information science for a long time, and really excited about data quality and metadata quality as kind of part of our core work. So it's great to have this session. A few years ago, probably about 6 or 7 years ago, we ran a series of sessions at ECIP on metadata quality and shared standards, that was part of the documentation cluster back then, which was more active. And from that, we generated sort of shared approaches to how to evaluate fair metadata that we're still using to this day in the Data One network of repositories across the world. And so this session was kind of inspired by that. Like Jeanette and I were talking about this and really hoping to sort of get some community sort of discussion going around what does a shared vision of data quality look like across the repository ecosystem. So the title of this session is Shared Approaches to Automating Data Quality Assessment Across the Repository Landscape, and we're really looking forward to the discussion here today. The plan is that we're going to have basically divide the session in 2 halves. In the first half, the first 45 minutes, we have 3 invited speakers who are going to give you perspectives about data quality assessment from their organizational approaches and tools and needs. And then in the second half, we're going to have a set of breakout groups where we try to brainstorm a little bit about what shared data quality looks like as well. To make sure I have all the ECIP things, I'll remind everybody that to please sign in to the meeting notes. So on the ECIP Kiko chat, you should be able to find this meeting notes document. That's the shared approaches document, and down a little bit lower, there's an attendance and check-in. It would be great to just have an idea of who's here, both virtually online and in the room. So please do sign in. We'll also be taking some notes here, and there are various links that are accessible from this document as well. So with that, I wanted to just start off with a quick definition of what data quality assessment might be. I think a lot of us talk about terms like data quality, but really mean a lot of different things. It could be assessing metadata quality. It could be really doing analysis of a particular data set for fitness, for purpose for a particular analytical task. It's hard to tell, but I found this definition from the EPA from the year 2000, which is still, I think, an active document that's sort of guidance document from EPA that defines data quality assessment as the scientific and statistical evaluation of data to determine if that data obtained from environmental data operations are of the right type, quality, and quantity to support their intended use. And I think that last phrase, to support their intended use, is the key phrase, because there are lots of intended uses. For some uses, it might be fine to have, say, low-resolution satellite data. And for other intended uses, you might need much higher resolution or data that's collected using a particular experimental protocol. So that intended use, I think, is key to understanding whether or not data have sufficient quality for your particular purposes. And that's what we're here today to discuss, to sort of figure out if there are shared approaches to representing data quality that we might have common ground on. So I've been working on both metadata quality and data quality issues for a long time, and we've started to think about these things in a couple of different categorizations. One is that if you're thinking about data quality and fitness for purpose, there's probably a way of categorizing things that thinks of generic quality checks that apply to any data set, regardless of discipline. So that might be something like, does this file, is it embedded with malware? Or does this file follow a data standard like NetCDF? Like those things really are not particularly domain specific. Whereas there are also project and domain quality checks that really only apply to a particular type of data. So you might say, have soil science data. You might want to find out if the soil horizon data that somebody's collecting conforms with a particular typology of soil data. Like that would be a very domain-specific check. And then some projects might even go beyond that and have their own project-specific standards and requirements. Once you've got a set of both generic and disciplinary checks, I think you can also think about characterizing the quality or assessing the quality of these data sets at different levels. You can do data set level reports that tell you whether or not a particular data set meets a particular intended purpose. You might do project level things to sort of understand whether your project is meeting your overall goals. And then you might do that at the repository or institutional level as well to sort of understand whether you as a organizational body are able to meet probably a set of different requirements or use cases for data quality. But all of these, I think, can be represented in ways that we can think of them as a set of particular ways of evaluating data that we might be able to collect up into suites that we can share and utilize. So the purpose of this session is to really focus on shared and automated data quality, and I thought I'd break down those two shared and automated columns a little bit. So when I say shared, I mean that there's a common set of use cases that we might want to evaluate data quality against. So it might be using satellite data for sea surface temperature estimation, or it might be some other use case. But there's some sort of a common set of use cases that we can share. We can have common code and systems that we can also share. So we might be able to use the same Python libraries to do evaluation of quality. And we might be able to share, for example, a reporting system. So if somebody does take the time to do a data quality analysis, can you communicate that data quality set of results to somebody else in a structured enough way that different groups can understand that? So as part of my work, we work a lot on interoperability among data repositories. And so we harmonize metadata standards in the Data One network. And one of the things I've noticed is that all of the data quality information in the Data One network, whether it's in ISO metadata or EML or the other various formats, it's all very high level narrative information about data quality. There's very little detailed structural information in these data set descriptors about exactly how somebody represented data quality. In contrast, there's oftentimes really detailed data quality checks inside of, for example, NetCDF files as check variables within those things. And so getting some common agreement about how we report back on data quality would go a long ways towards improving interoperability. And then in terms of automated, what we'd really love to see is a way that we can have a set of quality services that are triggered whenever data sets change and that produce these structured reports for everybody to be able to share and communicate about the data set so people can evaluate whether or not to use those data for a particular purpose. So at a high level, that's kind of the scope of what we're trying to talk about today. We are hoping to drill in a little further with 3 talks, one by Eugene Berger from NOAA about data quality there. Jeanette Clark will talk from the Arctic Data Center and the Metadata system, and Matt Biddle will talk about Cortod from NOAA and IOSQC. So let's start with Eugene, and we'll switch screens here and have Eugene, I'll let you take the controls here, okay?
Okay, thank you, Matt. And I'm ready when I can start sharing. Okay, here's the second. Okay, Matt, can you see the slides or slide?
Yes, we can.
Okay, good. Okay, well, thank you, everyone. And Matt, thank you for the invitation to present here and that introduction. And yeah, I really like the notion that you had in your introduction of quality control specific to the application of use of the data, because there are different levels of effort involved with that. So the introduction here that I'll give is, it really has 2 focuses. Firstly, I'm going to focus on one effort that we have here with quality assurance and quality control for data from uncrewed surface platforms. And then the second, I'm going to step into a pilot project that we had here with a different way to present quality control services. So Matt, I believe I have 10 minutes, so let me get going. So I just want to also acknowledge all the colleagues that have worked with me here at PML on this. And I'm at Pacific Marine Environmental Lab, where I'm Director of Research Services. I'm down the road from where you are. Unfortunately, I am unable to attend due to NOAA. Okay, so when we talk about data from uncrewed systems, it's not only uncrewed systems. What we're dealing with at the moment is a data buy environment for in-situ data, which is quite new to us in NOAA. This is rather a mature environment in satellite data where NOAA has been purchasing data for decades, but in situ data is quite a new concept. And how this differs, from the observing platform, NOAA typically purchases communication, develops the protocol, very often leverages protocols to receive the data via satellite. And when the data lands at the funding institution or institutions such as PML, we have to extract the data payload, parse the payload, manage the data through all those processes, and take responsibility for it. In a data buy environment, everything in this orange box is abstracted from NOAA. It's, we pay someone to deliver these data to NOAA, and they deliver these data to NOAA in a format that we define. And we happen to we specify that data from these data in situ data buy vendors for uncrewed platforms deliver data as NetCDF, fully documented NetCDF files. So there's a lot of abstraction there. So I just wanted to highlight this is what I'm going to talk about. And then on these uncrewed surface vehicles for the last 8 years, we've worked extensively with one vendor, Celdrone. We are expanding now to work with multiple uncrewed surface platform data vendors. But our all this development has focused on this one platform that is really set to a large degree for in situ data delivery, data buy delivery from in situ platforms, a quasi-industry norm for, I wouldn't call it a standard. And so this is the workflow from the platform. Data are delivered to Celdrone. Again, normally this would be delivered to NOAA, but with a data vendor, they receive the data. They take on a lot of complexity of unpacking the data from the payload and then getting those data to PML by FTP. And then we bring these data into our domain. And in doing that, we do this data integrity and QC check. And then we present the data through ERDAP, not only to scientists. We build services on the data rendered through ERDAP, but also these lines here to NCI, where data are archived, and then one of our weather service colleagues, National Data Boost, and harvest data where the data are placed on the Global Telecommunications Service. So it's just a workflow, simplified workflow of what we have, and we've been doing this for the last 8 years, or about 6 years, I'd say, and received hundreds of thousands of data deliveries for a large number of uncrewed systems missions. I mentioned the services we build. We build visualization services on top of the data that reside in ERDAP using ERDAP capabilities. And I'd just like to plug this. There is a work on a Sunfleet, which is just approved by Goose as a network, which is a global network of uncrewed platforms. And these are what these platforms look like. In case you haven't seen them, there's two models: the Explorer on the left, which is a smaller one, and then we're working now with a Voyager, which also has propulsion, electric propulsion. The Explorer is just wind and solar, and the Voyager, and also has a profiler, so we can get ocean profiles. And we're working on validating data from this platform. So on quality control, to step into what Matt asked me to speak about, we had past tense a developer here that has done quite a bit of work on developing a machine learning approach to quality control. And the approach was to characterize the behavior of sensors, of the suite of sensors in a particular domain, and then flagging anomalous or deviations from that behavior that was characterized by machine learning. We had quite a bit of success. This plot here shows an example where one of the sensors flatlined. I know it's a very simple test, but that the machine learning process red flagged all these observations that were flatlined, where the sensor dropped off and didn't have registered properly. So we had, I would say, moderate to high success in this approach. Unfortunately, we lost this developer with the recent spate of required executive order layoffs. So at the moment, this process we were at the point of integrating this into this workflow for uncrewed surface vehicles, and this process is stalled at the moment, and it's very unfortunate. But we had some moderate success. We hope we will soon be able to rehire someone to take on this work. But what we also do, as we receive these data, we receive as these data come in, we run a number of checks on the data to validate the data, validate the number of observations in the data that are delivered. And this has two objectives here: for mission managers to make sure that the data that they expect are coming in, and then also this is a contract we have with a vendor, so it's contractual compliance. And what I'm showing you, the screen snapshot I'm showing you here, is a plot from 6 drones. You can see the drone number 1030, 1031, and you'll see each vertical line here indicates one data delivery, and then the height of the line indicates the number of observations in that data delivery, and then if there's no line, it indicates no data are delivered. So very quickly we can determine that there was a gap in data delivery from all drones in this period, September 16, and then you can also see the variability. We see high variability in this drone, but very little variability in 1036, and that's what we want to see, very little variability. And this high variability in the number of observations delivered could be to power cycling on the drone or a failure of some type. And this system also allows us to drill down to individual observations and determine per drone how many observations are delivered for a particular parameter. And so it's a level of quality assurance that we can quickly verify how these platforms are performing and are we getting the data. And in this process, we also verify the integrity of the file, and the file is scanned for any vectors just from a security point of view. So this is a foundational quality assurance process that we do before the data are then placed into ERDAP, where data are accessible to scientists and other users. And then the next focus, I just want to briefly touch on this concept of a quality control as a service. And the objective really of this development, the pilot that we did a few years ago, was to establish, to see about or define the infrastructure needed to establish a federation of complementary quality cloud-hosted QC services that together will provide level 0 quality solutions to a full range of well-established quality control routines. And the well-established quality control routines is key here. So what's the objective? There are various clusters of expertise around the world on quality control. You could have AML Miami Lab that is specializes in underway quality control on dissolved oxygen and pH. Maybe in Bergen on chlorophyll and conductivity, and in Australia on these parameters. And the idea is that each one of these experts would expose their quality control services as a service on commercial cloud, so that someone that has data with these parameters will connect to all those services, send data there, and receive a response with these data annotated with regards to quality. And the idea here is that not only does this provide the same services globally, but that data would be annotated the same. And at the moment, the state of the landscape is we all install quality control software or develop it individually, and we have this various stovepipes of either duplicates of the same software or software that are custom written. And this requires control of the software to ensure they are the same version. And it could result that the same observation, here quality control by 3 entities received, are flagged differently. While it's just because different software is used. And the objective is that all of us would use these QC services, QC as a service, connect to that, send data, and you receive a response with the data then flagged. And the idea is that these cloud-hosted quality control services are validated quality control services that the community has agreed on, and then collectively, globally, that one could connect to these various services to quality control data. So we did a pilot with AML and with Bergen and ran a couple of tests. In situ, this is focused on in situ observations. The volume isn't that high, so sending these data over the cloud, over the wire, and getting a response back is doable. For satellite data or model data, that's more difficult. And the idea is that you have these cloud services and various users, depending on what data they have, that connect to these services. And we developed a definition on how you get information on these services, and then how you submit data to those services. And a diagram just to indicate the basic infrastructure that we developed. So Matt, I will stop there and of course answer any questions if there are any. Thank you very much. Matt, we're not hearing you.
Sorry, I didn't hit the mute button. So yeah, thanks, Eugene. That was fantastic. And if there's a question or two for Eugene while we're waiting, please go ahead and ask it, and I'll switch over to Jeanette here.
So I'm Jeanette. I'm a research software engineer at the Arctic Data Center, and so I'm going to be talking about data quality assessment at Data One, but I'm primarily going to focus on the work that we've implemented at the Arctic Data Center. So if you don't know Data One, it's a federation of data repositories with 68 members spanning a huge range of disciplines within the earth sciences. And one of the tools that we have, pieces of software that we have implemented on Data One, like Matt mentioned, is our FAIR metadata assessment, where for every data set that comes into Data One, we do an assessment of its metadata according to FAI and R. There's 52 checks in this suite that do things like check to make sure that there's a publication date and it's not in the future, or check to make sure that the abstract or the title have an appropriate length. And so we've been running these checks for some time. They were developed at an ESIP session in 2019. So 90 checks were discussed and 52 ended up being implemented. And we've been running this in our production system for some time now. It's built on this foundation of extensible suites where we have individual checks that are in their own XML documents that contain the identifier of the check, a description, the environment that the check runs in, and then the actual code itself. And then you can mix and match these checks into different suites. For example, like the most recent FAIR suite contains 52 of these check documents. And so we don't just run the FAIR suite. We have an Arctic Data Center suite. We have suites that are specific to other repositories. And since we're in this data quality session, you may be expecting me to say that we are developing a data quality suite. We're in this session in part because being able to run automated data quality assessment is becoming increasingly important as we have these really large data sets and large data set processing pipelines where there might be 5-6 steps that take you from petabyte scale imagery down to some visualization. And it's important to know that your data are of high quality at each step along the way. However, it's way too much data for any one person to look at. So I'm going to be talking about a couple different needs that we have in terms of this data quality assessment. One that I'm only going to spend one slide talking about is that it needs to be scalable over large volumes. So these checks need to be able to handle large volumes of data. Each check actually looks inside, Each check actually looks inside individual files. And so when you're passing a lot of volume through, the infrastructure needs to be able to handle that. And so at NCEES, we're running this on some self-hosted cloud infrastructure using Kubernetes and Ceph that we have in our North Hall data set that can handle the 120 or so terabytes of data that we throw at it. The next need for us at Data One in the Arctic Data Center is we need to be able to support diverse disciplines. So we need to write checks that can run on a really wide variety of data. And this is in contrast to Eugene's talk where, they're really focusing on this very narrow type of uncrewed systems. At the Arctic Data Center, we have lots of data sets on everything from oceanography to political science to archaeology. And so our checks and our data suite needs to be able to handle that. And so with that in mind, we've developed the version 0.1.0, really like a proof of concept set of checks. And I've divided these checks and thinking about these checks into two different categories. So we have generic checks, like Matt mentioned. So something like a malware scan, like we want to make sure that no one's slipped malware into our data repository. We want to make sure that our data files the characters match the declared encoding, or that they conform to particular standards, like NetCDF conforms to NetCDF standards. And these are generic checks that don't require any domain-specific knowledge. You can run them, maybe not on every single type of file, like you wouldn't run a NetCDF check on a text file, obviously. But you can run it on an oceanography, an atmospheric science, geology, the discipline doesn't matter. And this is in contrast to domain or discipline specific checks like outlier flagging, checking for data model agreement, tree diameters shouldn't get smaller. So these are checks that we're not implementing right now at the Arctic Data Center simply because we need domain and discipline specific knowledge to actually write the checks. So I'm going to be focusing on these generic checks and talking about how we've implemented those. So this is the preliminary version. There's 12 checks in here. You don't have to read all these, but I'll just describe briefly. So we have 2 checks that look at every single file, checking for malware, and then checking to make sure that the format of the file matches the format declared in the metadata. And then we have checks, a variety of checks aimed at text-delimited tables. We get a lot of CSVs and TSVs, so checking to make sure, for example, that the missing value codes in those files are documented, or that the column names match the documentation. Shape files, we want to make sure that those are complete within zips without unrelated files. And a couple of checks related to netcdfs, so looking at global variable and coordinate attributes. So this is the preliminary version of the data suite, and here is a figure that has been a long, long time in the making, and it's not like the most important figure for this talk, but we put in a ton of effort to be able to actually create this figure. So these are the results of our data suite run over about 7,000 data sets. On the right-hand side, you can see the number of files that were actually checked. So like I said, we're not running netcdf checks on text files, obviously. So a couple results to highlight. We don't have a lot of character garbles, and we had only like a small handful of malware hits that were all false positives. So that's good news. The sort of medium news is not surprising to me at all that a lot of our CSVs are slightly malformed, not documented correctly, have some issues. Like, for example, the variables congruent percentage is pretty low, which doesn't surprise me because the check is very strict. It requires a character for character match. And then the less good results are these netcdf checks that, so this is checking against some of the CF and ASSD recommended fields. It's not even that strict, but a lot of people are submitting netcdf files that don't conform to those CF or ASSD standards. So that's interesting. And part of the reason why I'm really excited to be here for this session is because we become what we measure with regard to these quality checks, and community consensus is going to be really important as we develop and implement these checks in an interoperable way. And you can see this in these 2 figures. So on the left side, this is a preliminary version of the FAIR suite with 23 checks, and on the right side with 52 checks. So the results are quite different depending on, in the overall FAIR scores, depending on what you check. And you can think about this, like you can throw yourself a bunch of softball checks that you're going to pass, or you can put yourself, test yourself against a really, really strict set of requirements. And so it's up to us to decide what these requirements should be. And as an example, I ran into this problem with the shape files is should SHX files be required in shapefile sets? The Esri documentation says that they should be, and they actually don't even list the PRJ file as a required file. But our current check doesn't require it though, because you can regenerate SHX files if you have the SHP file. So these are the types of like nitty-gritty questions that we probably won't answer in the breakout session, but maybe that we could start to approach a discussion of what's important, what's not, as a community when we think about these generic checks. And then lastly, I'll talk very briefly about check output. Matt mentioned this as well. When we work interoperably, we really want to have quantifiable interoperable result reporting. We have our, check results that show up in our landing pages on Data One in the Arctic Data Center, and those are backed by structured XML documents. But it would be really great if we could get to a place where we're actually annotating data sets, either at the measurement level, the file level, the data set level, with these annotations from vocabularies that other repositories also use, because we're all going to be probably running different infrastructure, but if we can, coalesce on some of our output, it's going to increase the interoperability of the data themselves when you're able to figure out, like, is this fit for my purpose by looking at this output? So in short, let's collaborate. I'm excited about our breakout sessions. And there's a little plug for the GitHub repository if you're really into adding check ideas. I'm all for it. So thanks, everybody.
So questions for Jeanette while we get Matt set up? You should, yeah.
Yeah, thank you for the talk. And this may also be a question for Eugene, because it's reflecting on both of those, which is that you've kind of talked about two different things together. One, which is doing data quality assessments sort of in real time, so to speak, or while something's collecting data so that you can ensure things continue to collect data correctly or at all. And what you're talking about is more sort of, call it post hoc, but validating that things.
Jeanette, can you repeat the question because I accidentally muted them, not
yeah.
realizing that it was the other one, so, yeah.
Yeah, so the question was, Eugene and I talked about two ways of approaching data quality. One, Eugene, where the data are coming in real or near real time, and our approach, which is, we get the data into the data archive and then we run the data quality checks, and how might those two sort of frameworks interact, or, is there commonality between the two? Eugene, do you want to go or should I start?
Please go ahead.
Okay. Yeah, I mean, I think it's an unfortunate, to me, reality of the data archive world is that people often publish their data sets to data repositories when they're, done with the paper, with everything. In my ideal world, researchers would publish intermediate versions or initial versions of their data set where the data quality checks would run on them automatically, and then they would actually use that feedback to, in their data collection or data processing, downstream of that to, like, as a tool. And that's sort of part of what we've envisioned with our data quality suite and some other tools that we have at the Arctic Data Center, is to try to encourage, use it as like a little bit of a carrot to encourage people to upload their data sooner in the process. As barring that, someone who publishes their data at the very end, after they've published the paper and so on, you still might catch important issues in the files or in the documentation. I talk about data quality checks, but a lot of those checks hinge on the metadata as well, and it might not actually be a data problem, but a metadata problem. So I think that they don't have to be as dissimilar as they seem from Eugene's work. But yeah, that is an important difference to point out in terms of the workflow is, it's always going to be run sooner on the system that Eugene is talking about. Do you have anything you want to add?
No, but just from a timing perspective, Eugene, is it okay if we move ahead with the?
Yeah, Jeanette addressed this.
Okay, thank you. So Matt, go ahead, and you've got 10 minutes.
All right, can you hear me? Hopefully it's coming through. Yeah, my video is all messed up. I don't know what's going on. But I got 10 minutes. I'm going to do a little dive into Quartod. First and foremost, I want to say thank you to Eugene, Jeanette, and Matt for inviting me. I'm really glad to be participate in this session to talk about shared approaches to automate data quality assessment across the repository landscape. I'm going to dig into what we call the quality assurance and quality control of real-time oceanographic data. So hi, my name is Matthew Biddle. I sit at the NOAA's Integrated Ocean Observing System Office, and I am the data management and cyber infrastructure community manager. So my job is to go out and talk about all this stuff and work with the regional associations to align their practices to current data management leading practices. And so what is the US IUCE? We are a collection of 11 regional associations around the coast, oceans, and Great Lakes. We collect a variety of oceanographic data, from high frequency radar data to animal tracking information. There's a lot of buoys deployed and gliders deployed and all sorts of different types of things. And so one of the things we do at the national office is we try to coordinate all of these observations and provide data management practices to ensure the I in IUCE is actually happening. We can actually integrate all of these different observation types across all of these different regional associations to inform the local communities about what's going on in their local ecosystems. So what is CORTOD? CORTOD, again, is the quality assurance for real-time oceanographic data. The key objective of CORTOD is to sustain a process for establishing QA/QC procedures. We want to establish authoritative procedures for these 34 core variables within US IUCE. Now, these core variables are like temperature, salinity, and going on into plankton, and then a whole bunch of different other types of variables. But we want to include detailed information about the sensors and the procedures used to measure the variables. So CORTOD is not only the quality control checks, but it's also how do you deploy the instrument? How do you go out on a ship and do the maintenance for a buoy or a mooring? So we're producing written manuals for the different QA/QC procedures. From those different lists, we develop these guidelines and define this baseline set of procedures that can be used for the certification of RCOS data providers. So the RCOS is Regional Coastal Ocean Observing System. So those are the regional associations. And what we do at the US IUCE office is we actually provide a certification for them to say that the data that they collect is up to NOAA standards for observational data. So what'll happen is if there is some sort of a lawsuit that comes about for those data, NOAA Legal will actually step in and say, no, these data are collected up to NOAA standards. And that's because they're following, the CORTOD QA/QC procedures. We also want to facilitate the integration with the Global Ocean Observing System. So this is getting the I in FAIR, that integration, making sure that everybody understands what our quality flags are and how to interpret them. And then we want to engage with other federal agencies in the regions to make this a community developed system. So it's not just IUCE coming out and saying thou shalt do. It's developed by the community, run by the community. You might have heard of CORTOD before, because I know Mark Bushnell has given a lot of CORTOD talks within the ESIP community. So what we're trying to do is build this community around what the ideal conventions are. And then we want to work efficiently, of course. We don't want to duplicate effort. We want to facilitate the implementation of these common procedures within the US IUCE partners, and then extend those beyond IUCE. So where do we stand right now? CORTOD, we have 13 manuals, and then we have a manual on how to identify the quality control flags. So these manuals, like I said, describe how to deploy some instrumentation, some guidelines on how to do initial setup and locations for where these instruments should be deployed. They also provide information on what the quality control checks should look like. So what should a flatline test look like for pH data observations? Or what does a spike test look for in situ current observations? Those are going to be different types of things. And then what each of the manuals gives is just some guidelines on how to go about setting up the instrument, and then how to run your actual QA/QC. All of the manuals and all the information is available on our iuce.noaa.gov. You can go to that website. And all of the manuals are actually published through Ocean Best Practices. So we set up a group within a collection within Ocean Best Practices for CORTOD itself. And you'll see there's a lot of presentations in there linked as well, but there's a whole bunch of materials, and all of the manuals are actually linked on there with digital object identifiers. So we have citations to go back to the manual to say, this is the test that I ran and this is what I followed. Let's see, the 7 laws. So these were written in 2003. They still apply. The concept again is we're a community that are building these quality control procedures, and we want to build them from the ground up. We want to have community backing and support instead of coming in with this is thou shalt do, like I said before. So every real-time observation distributed to the community must be accompanied by a quality descriptor. Now, what Quartod is intended to be is that like level 0 check. Like, is this within reason for an observation? It's not intended to be that human check where we're doing kind of what Eugene was talking about, where we're getting into the AI ML of really trying to get into the nitty gritty of the checks. These are supposed to be the high level, like, are you within range of what a temperature observation should be? And so we're saying that, yeah, every observation should be accompanied by those. They should be subject to some level of automated real-time quality tests. The flags and the test descriptions should be sufficiently described in the accompanying metadata. Luckily, a lot of the file formats that we use are NetCDF, which allow you to have that accompanying metadata with the files to just fully describe what the flags are that are associated. Those flags should be independently verified, and then the sensor actually should be calibrated. So this gets into that description of how do you set up the sensors when you're just deploying them out. There should be some descriptions. This is getting into the metadata information about the method and calibration in real-time metadata. And the observer should qualify the level of calibration accuracy associated with the expected error bounds. So this gives you more of that metadata, the additional information to understand how you can do better QA, QC down the road. And then manual checks should be done at some point. But again, Quartod is one of the like initial bounding box, I like to say, for quality flags. So where are we at right now? We have Quartod is actually run with a board of advisors. So, and I don't remember how many people are on it. Hopefully Eugene could save me with that number. But there's a group of folks that come together, and we help assist where Quartod should go, what new manuals we should work on, and what new development. Thank you, Eugene, 7 members. But the focus right now the quality assurance for real time is real-time QC manuals. So that's really helpful for implementing automated QC, but what it requires is interoperable data streams and data used in real time, the RT of Quartod. So this doesn't help us with other observations like passive acoustic data or eDNA or biological observations, which might take a little bit to get down the road, and the real-time aspect gets a little bit lost. So those are the areas that we're trying to start exploring right now. And what we do is we build a user community around each of the manuals, and that user community helps us define what's going into the manual and the description. We've also been fully supportive of developing tools to help implement Quartod. So we actually have this IUSE_QC package, which implements Quartod and then a couple other quality control tests, but it's a Python package that you can run on your real-time oceanographic data to test against a few of the Quartod tests. Excuse me, apologies. So what are the main activities is we want to foster this implementation of existing manuals. So this is what I'm doing right now is, hey, we have manuals, everyone go use them, they're great. We want to update those manuals with any new things. So as this AI ML starts evolving, how does that play in these manuals? How do we update that to update the manuals to reflect those changes? And we want to work with the communities to develop any new manuals as needed. We also have some interaction with international entities as much as we can, and doing a lot of promotion of outreach and working with manufacturers to actually embed the QC tests in the instruments. I have like half a second. I'm going to try to quick run through. So I wanted to do a quick test. Hopefully you all can still see my screen, of actually running the IUSE_QC Python package to highlight the interoperability of using some open source code to run quality control checks, to be able to go back and say, hey, these were the checks that I run, and we can we have that provenance associated with our data. So this is background about QA QC, but we have some data from Alaska that's out on an ERDAP server. We can see that there's some spikes, there's some flat lines, and then we have some up and downs going on. But what we're going to do is take a look at that data, and then we're going to bring it in and actually build a quality control flags. So we have the Cortod test. In this is a JSON of how to build the flags. We have the Cortod test. We have a gross range test that gives some suspected span and then fail span. So the suspected span is we think it's going to be bad here. Fail span is going to be no good outside of there. And then we have our various tests that we set up. And what we can do is we can run our data through that configuration and it'll return all of the flags associated with this. So these flags are identified in that QC flag manual. And so we have a data didn't pass, it didn't run on this data point, it was suspect, it failed. And so we can start getting some outputs and getting those flags. And now those flags can be reincorporated back into the NetCDF files to accompany the data as they go on. But now we have this interoperable code that people can reuse to analyze their data or look back at the data to see how the flags were identified. I am out of time, but I wanted to say thank you for having me in here. And I have one more mention. Eugene was talking about quality control as a service. One of the things that we've done this year through IUCE and the Google Summer of Code is we've developed using, I forgot which app, I think it's like Pyodide or some Python tool to use that the IUCE QC package and make it a web tool using GitHub and using Python. So now it's using that core package and now it's a web accessible tool. So we're starting to get towards those quality control as a service through this package. That's all I have. Thank you so much. And sorry, I went a little bit overboard.
No, thank you, Matt. That was fantastic. Really appreciate the background. Okay, quick question for Matt while we switch over to get the breakout groups ready. Is the microphone somewhere? There you go.
Can you talk a little bit more about what the user experience for that web tool will look like, or what that flow is expected to be?
So I can drop a link to it. It's in development. It will hopefully by the end of summer that student will have finished and there will be a product out there. But the idea is it's a web app with drop downs, and you set basically that dictionary that I showed in that example. You set that dictionary up in the web form. So you upload your file, you select what test you want to do, and then you set your configuration in there's just little empty spaces that you fill in your values for it. And then it'll plot and it'll run that QC test, and then it'll bring back your results.
Okay, thank you, Matt. And so we're at about the halfway point here, 2:51. Good job, everybody, on the speaking. So what we're hoping to do is to spend about a half an hour in a breakout and then come back and sort of just have very brief report backs from each of the three breakout groups at the end. Maybe not trying to summarize everything that you talk about in the breakout, but maybe come up with a couple of highlight points that you think might be particularly useful to share. So the plan is we're going to break into three groups, two of them in this room. So like maybe we're not quite half and half, but we'll try to do half and half of the room. So I'll lead one on this side, Jeanette will lead a group on this side, and then Cindy Garcia is online and will lead a Zoom breakout. And the goal for each of these breakouts is to talk about what are the types of both data quality checks and software that we might be able to share as a community to build automated systems that interoperate and work well together. So there's three different types. We're thinking about what are the generic types of checks, as Jeanette framed it, that might be worthwhile for all of us to be implementing as data facility operators, as researchers, and the other roles that we play. Whoops. So you're trying to open up a breakout room for the, yeah, that's okay. I think because all the Zoom participants will be in one breakout room, they can probably just stay in the main room, right? Yeah, so I don't know, how many Zoom participants are there? 14. Yeah, it's a little too big, but I think we'll have to go for now. So, okay, so So yeah, the second of these,
You still probably want to open breakout rooms, otherwise we can all hear when they're talking.
that's a great point.
So yeah, I'll open it when it's finished.
Okay, I'm gonna close that. So the domain-specific checks, and then software tools that people might be able to utilize, whether that's something that, like Cortod and IOSQC that already exist and that a whole community has a really mature model for, or whether it's new platforms that serve other domains and disciplines or generic types of tooling. And so what we've done is we've put together a spreadsheet which looks like this. If you go to the session notes in the resources for this session, there's a link to this breakout session, but basically there's a spreadsheet that has 5 tabs. There's a different tab for Group A, Group B, and Group C to sort of brainstorm data quality checks. You're welcome to put whatever you want in here, but I've seeded it with a bunch of the checks that Jeanette was talking about, just to give people an idea of the kind of granularity, but you're welcome to go higher level or lower level, whatever is most useful. And then we tried to categorize them as like their level of generality, where they're super domain specific or more project specific or more general, comments and notes. And if there's a piece of software that already implements that, we'd love to know about it. So like, is there a tool support for that check in any particular software things? And so we noted a few of these that Jeanette has implemented in the Metadig system that we were talking about. So there's a separate tab for each of the breakout groups to talk about those different data quality checks. So find your appropriate tab. And then I created another tab, which is just a list of the software. And so both frameworks and libraries, tooling that people might use both generically and in particular disciplines to do QA work. And so if you know of a tool in your breakout session, it would be great to sort of capture some information about that so that we can sort of crowdsource a bit of knowledge around what kind of QA work people are doing across the different disciplines. So the plan would be for each group to have that discussion. Feel free to go further abroad if you want to talk more generally about other items than this specific tasks. But then when we'll reconvene at, let's say, 3:20 and get like a 1-minute report back from each group or something like that. All right, so thanks. So let's, I just kind of want to evenly split 2, 4, 6, 8, 9, 2, 4, 6, 8. Yeah, that's pretty evenly split right down the middle. So let's just do that. And Cindy, are you all set online?
Yes. Are we staying in this general room here?
So Bolivar is going to set up a room for you to join here in just a second. You should see it pop up.
Sounds good.
There it is.
Thanks.
Okay, so Zoom people should join that breakout room, and then, yeah, we'll see you back here at 3:20.
Who's who?
I think I'm A, you're B, Cindy is C. All right, I'm going to mute this, okay?
Yeah.
Well, thank you, everybody. I hope those were profitable discussions. We had the 3 groups. In our group, at least, we completely deviated from the plan, but that's okay. It was really great conversation. Yeah, so why don't we start with quick report backs? I'm going to see if, Martin, are you willing to do Group A? Oh, so hard. I'm going to give you a microphone even so you can think while I'm...
Definitely not. I don't know. Okay, so what we talked about was really trying to figure out if there's a need for data quality control mechanism for repositories, for data management, and that could be shared across different organizations. And the consensus for yes would be good, but that there's a difference between what the data producer would do and what a data repository would need to do. because they have different needs that they're reporting back. So the data producers really go to the detail that needs to be specialized, while the depositories need to be, the metadata is more important. So, and all agree that that is important to do this. Anything else that we need to, okay, yeah, there was the idea of really coming up with a combination of AI and QA tools, and that would be figuring out what would be the best group to help with this. It would be an ESTIP cluster, it would be maybe the CDF or some other people who could help with finding a community around this, as it seems to be there's a need and an interest in building something like it.
Yeah. Yeah, I think the discussion at the end there was great, where we talked about, could we either use an existing cluster in ESIP, or like the SOSO model where schema.org got sort of brainstormed really quickly in a year and a half, come up with something that's really helpful through a very focused amount of work through a group like ESIP. So I think that would be good. I'll let you off the hook, Martin, unless, does anybody else have any comments from this group? Okay. So let's do online. Cindy, are you ready?
Matt Biddle will be presenting for Group C.
Okay, perfect.
Yeah, my video broke, so I got defaulted to present for our group. So that's what happens. Yeah, we actually had a working session, I'll say, where we added 24 new lines into your spreadsheet there, Matt. So we got a lot of new data, a lot of new points to work with. There was some interesting discussion about Esri data files and if they're actually open source or not. And there was, I learned something new, that yeah, Esri published the standard, and so other software can build the readers. So it is considered an open source format. So that was something new I learned too. There was some comments about long versus wide, going into semantic annotation, that I think in the long format, you're unable to add semantic information to the metadata with in metadata formats such as like the EML format. So that's where it kind of conflicts a little bit. There was also some checking lines added in about column name matching metadata. So some consistency across where you might look in a data file and what it looks like in the metadata itself. Sometimes those are keys, so there needs to be some consistency in there. For trajectory data, this could overlap with a lat long check, but also like a platform speed check to see if that's within range. So again, going to range checks and things like that. So a lot of these might be subsets of things that already exist in there. I think the next step would be looking through the giant list that we have and seeing what's consistent across those and how they can be binned. And then we had some conversation about column names containing spaces and capital letters, and just consistency across file naming, or across column naming. So there was some mention of that. And then we had a conversation about time in data files and whether that should be a requirement. And in some cases, time is not always a requirement, because there are experimental data sets where a benchtop experiment was done and time might not be as relevant. And then some conversation about fill values and consistency in fill values. And there was a use case of fill values changed at 3 different sites for the same data set, and somebody had to decipher what was going on with that. So some consistency there. And I think that was it. Anybody else from the online group have things to add?
That was perfect, Matt.
Cool.
But there were also lots of autonomous platform operations, QC, maybe because of the composition of the group as well. And also Arctic and marine specific validations because of, discipline specific, but yeah.
Okay, last group, Group B.
Yeah, I forgot to designate a reporter, so I'm going to do it.
Okay.
So we had really interesting and kind of wide-ranging discussion. I'll hit on a couple points in no particular order. One interesting idea that came up was around this sort of fit for purpose question, and what purpose are we talking about? And something that's fit for one purpose may not be fit for another. And so there was the idea floated about like actually annotating, fit for AI ML. This is coming from the AI readiness group. I'll plug their session. What is it, tomorrow? So this idea of whether we could, subcategorize our sort of suites or checks according to, different purposes that, so like, is this fit for, are these in situ measurements fit for purpose? Or, you can think of a variety of different examples there. We also talked quite a bit about variable names as well, and added a couple lines to the sheet, going from the very specific, like our variables in the Darwin Core vocab from one of our group members, to just thinking about, are the variable names in any vocabulary, and how harshly do you want to penalize that if they're not, since there was some discussion about this limitations of the CF vocabulary in particular, about how certain vocabularies are tailored to different disciplines. And then also some discussion similar to the online group about spaces, special characters, and variable names. And then we also talked about some of the intricacies and challenges of shipboard, QA/QC, and the work that the R2R is doing in trying to harmonize those data sets and implement automated quality checking there. Did I miss any major points? Okay.
All right, well, thank you, everybody. Like, as you can see, Jeanette and I are launching into a sort of an attempt to build a system for Data One like this, and we'd love to have more community discussions around what would be useful. And I'd love to maybe try to continue this discussion. I don't know if it's in the AI readiness discussions or in some other ESIP cluster discussions. Or it could be under CDF, yeah, that would be too, yeah. So, yeah, maybe CDF, but let's try to online figure out if there's a core group of people that wants to really sit down and dig in deeper into this. We're excited about it.
CDF has a session tomorrow.
Yep.
So you could just bring that up at that session.
Yep, all right. Thank you, everybody, for your stuff, and thanks to the speakers, Matt, Eugene, and Jeanette. I really appreciate it. And Cindy, thank you for moderating, and yeah, everybody have a great break. Good ESIP.
Thank you, Matt.